Right, good evening, everyone. I hope you had a wonderful day. Right, we are still looking at Loci, and in particular, we are looking at the helix. Today's discussion focuses on the springs. So we want to see how the concept of the helix is applied to the world of industry, in particular with regards to springs. Right, so it says here, with regards to our content, we are still looking at the loci. We have got the helix in particular, right? We have got application of the helix, and we noted the springs. So we just want to give a brief background of what these springs are. So we have got the definition of a spring. Helical springs are made up of a wire coiled in the form of a helix and are primarily intended for compressive or tensile loads. The cross-section of the wire from which the spring is made may be circular, square, or rectangular. Right, as you can see from the highlight, we are going to focus on a square spring. And what is the use of the helical spring? The helical spring, in which wire is wrapped in a coil that resembles a screw thread, is probably the most commonly used mechanical spring. It can be designed to carry, pull, or push loads. Twisted helical torsion or springs, or twisted helical, which basically are torsion in nature, springs are used in engine starters and hinges. So we now want to focus on the construction of the square spring. Remember, don't forget this. I hear and I forget, I see and I remember, I do and I understand. The most important part is the doing part, so that you are able to understand the concept fully. So let's get straight to it and do the practical aspect of this discussion. Thank you. Enjoy the lesson. Right, okay. Now, this is the scenario that we have today. Right, we have got the given information, the top view of a square spring showing the starting position. Right, when you see this mark, it shows the starting position, okay? Right, then the specifications, we have got the direction, it's left-handed, then the number of turns, right, it's 2 turns starting at the top. Right, remember, this is our top view. We are going to derive the front view from that. The spring profile is 12 millimeter by 12 millimeter. Like we said, it's going to be a square spring. And the pitch is 48, okay? So from one point to the next point at the beginning of the next turn, right, we have got the pitch. So basically this is about the longitudinal distance covered, which is the length from one point to another similar point. We refer to that one as the pitch. We described this on our day one discussion with regards to the terms or terminologies that are used in the construction of the helix. Right, starting at the start position, draw to a scale 1:1 the front view and the top view of the square spring. Right, like I said, we are given this one, that's our top view. So we are going to draw it fully, okay? We are not going to draw it as a half component, okay? All right, so what you need to do, first of all, let's define the position of the sender. Faintly, like that. Right. The outside diameter is diameter 78, right? Which means the radius is 39. Then the inside diameter is 54. Now, if you check, right, 78 minus 54, you get 24. So what it means is that from here to there is 12, from here to there is 12, this is also 12, which is the thickness of the spring itself, okay? And what is critical in with regards to the construction of a spring, okay? Right, you are going, of course, to imagine that there's a shaft, which is the inside diameter, but you need 4 helices that you are supposed to draw. Then you take out the shaft at the end of the day. So you can have a spring which can be squeezed, which are the compressive forces, or which can be pulled, which are the tensile forces, which it should act against. I'm going to draw a fade line like that. But then measure 39 as well as 54, that's 27. But just to check, this should give us 12 millimeters, which is perfectly all right. Then you take your canvas, open to radius 39 and describe a circle like that. Then the other one, just there you go, okay? Right, now we are also given the start position, right, which is defined by this line. So you have got that. Right, so we are going to start this side, right, but in the same vein, we can also show the center line, just like that. Right, before we define the center line for the front view, right, we need to establish the height of the spring itself. Now we are given here, right? They say this is 48, which is the pitch, right? So if it turns twice, so we are going to say 48 times 2, which would give us 96. So with one starting position, we have got 96, but because another position would start always want to illustrate, right, okay? So you have got here, like this, right? We defined this, right? And also the other one like that, okay? Right, then we are going to take this one down, start position, that's the center line, right? So the first part, right, is from here, right? That's our point 0. Right, then the other one would start 12 millimeters later, which, right, to give us the section of the spring. So we are going to have another one here. So the first one would start from here all the way, right, to this height, which would give us 96, okay? But that is that, okay? Now, the other one should also still give us 96. What it means basically is that we are going to add 12 millimeters here. So from here to the added 12 millimeters, we still have got 96. So altogether, right, altogether from the start up until this one, that is the distance that we want, okay? Right, so we have got 96 plus the 12 millimeters. Let's just check. 96 plus 12, we are going to get 108 millimeters. So the height, the overall height of our spring would be 108. So let's measure that. I'm going to do this. Mark a point and something here. Okay. There you go. Right. So this is the height. Now we can bring the cylinder. And also even bring this one down. There you go. Now I can even define the center line. Right. So the center line with regards to the drawing, it's now in position. Take this one down. So that we are able to see fully, okay? Right, so from here to there, that's 108. We have defined the center lines. Now, we know that if we are talking about 2 tens, right? 2 tens would give us 24 divisions, okay? Right, we are going to get 24 divisions like that. Now, in these 24 divisions, basically they relate to a height of 96, okay? But this 96 has now been increased to 108, okay? In terms of millimeters, like that. So what is the number of divisions then? So we can cross multiply like that, so that this is our X number, okay? Right, so it's going to be 108 divided by 96 multiplied by 24. Right, we are going to get 27 divisions, okay? So therefore, X is equal to 27 divisions. That is the total number of divisions that we require, okay? The other option, you can say 96 divided by 24, right? So 96 divided by 24, you get each division is equal to 4 millimeter in terms of the spacing, okay? So how many of these 4 millimeters would get into the additional 12 millimeter, okay? So you are going to get, say, 12 divided by 4, which would give you 3 additional. These are additional, plus the 24 that you already have. The answer would still give you 27 divisions, okay? Right, so there are 2 ways to look at it in terms of the total number of divisions. Right, so I'm going to divide this height into 27 equal parts. Right, now if I don't have space there, you can easily come here, right, like that, divide even this height, which is the center line. Right, I'm going to do this like that. Right, 24 would give me extend this. That's 18, that's 26 at 5 millimeter intervals. Ideally, you should do it outside in order to make your work presentable and neat. But if you don't have space, you can do it like this. Right, we connect this one to there. Take one of the set squares, align. There you go. Right, so now there are 27 divisions here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay. Then you project these ones horizontally now. Technically, these are at 4 millimeters apart. But because they are marks which are awarded, it could be 1 mark, it could be half a mark for showing that division. So if you have got time, you need to show that, okay? Otherwise, you would lose that half a mark or that complete mark. There you go, okay? Right, so these are the horizontal divisions now, right? Then once you have done that, you also divide the top view into the same number of divisions, in this case, into 12 equal divisions. So we have got that. But whenever you are doing this, just make sure that the lines slightly cross so that you'll be able to identify clearly the point of projection. Right, okay. Right, so this is our point 0, which is the same as that one, which is our point 0 as well. All right, so we are going to say 0, 1, 2, 3, 4, 5, 6. Then let's take note of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is another 0. So the distance from here to there, that's our pitch. which should technically be equal to 48. Then we have got 1, 2, 3, 4, 5, 6, half a pitch. Then we label 7, 8, 9, 10, 11, 12. Right. So from here to there, that's one full pitch. From here to there, that's another complete pitch. Then 1, 2, 3. These three divisions are representing that additional 12 millimeters, right, from the two chains that we noted, okay? Right. So if we start from here, the other start would be here, okay, in terms of number 3. Right, so let's project these lines downwards. What is also critical and important is left-handed. Left-handed should go anti-clockwise, and we are told that it's starting at the top. So we are going to say this is point number 1, this is 3, right? This is 6, and 9, back to 0 like that. So we are going to project. The other one is here. Right, start with the outside diameter. There you go. Okay. Right. So we have got point is 0. This is 1. Right. This is 2. That's 3, 4, 5, and 6. Right. Correct. 7, 8, 9, 10, 11, 0, which is one complete 10. That's 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, and 0. Right? Then you stop there. Don't go beyond the number of tens, okay? Otherwise, you end up making a mistake. So you draw a line like that, a curve. There you go. Right, like that. Okay, don't worry about if you make some mistakes, you are going to absorb that when you outline. Now, the other starting position would be this one, right? But this one is for the inside. For the outside, it will be this one. So I'm going to say this is now 1, 2, 3. 3 divisions are representing 12. So from here, that's 0, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 7, 8, 9, 10, 11, and 12. 1, 2, 3, correct. 1, 2, 2 here, and 3, 4, 5, 6. 1, 2, 3, 7, 8, 9, 10, 11, up to there. Then you connect this one as well, faintly. right, like that. So I now have got the two helices, right, with the starting position, this point and that point. The next thing that you want to look at is the issue of the inside part. But once we have done this, right, you can even outline that part which is going to the left, which is this one is going to the left, this one is also going to the left, right? But maybe let's wait and complete everything so that we'll do the outlining later on. Right, project from here, that's the inside. There you go. Right, like that. So the first point that we want is this one, right, which is 0.0 in line. So we have got now 1, right, then 2, 3 is common, 4, 5, 6, 7, 8, 9 is common, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, you connect these ones nicely. There you go. Okay, right, so that is the smaller one, which is attached to the shaft or the presumed shaft because it's not there. Right, then another 0 would start from here, then that's 0.1, that's 0.2, 3 common, 4, 5, and 6, 7, 8, 9 common, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like that. Then you outline this. There you go. Okay. Let me just bring this on to the phone. Right. Now that we have got the framework in terms of our spring, right, so the next thing that you would need to do, right, is to outline the big helix, which is going to the left. So I'm going to start with this one. Stop there. Right, then we will do the same. Like that. That is the big one which is going to the left. Then if we also come here, there's another one. Like that. Then the next one is this one. Like that. Right. Once you have done that, this is closing, right? Like that. This is face down, right? Now, you would see that this one is now going to the left, it's going to the right, this is going to the right. So what it means, therefore, right, this part, you are going to define it and show it as a section, like that. The moment you have shown that, you take your set square and H this part so that you won't forget, because this is the section of the square spring. There you go. Right. The other thing, you also close this end and you also close this one. Right, you do the same this side, close and close like that. The next thing that you need to do now, right, is to outline, right, the smaller helix which is going to the left. Okay, right, we have got from here to there, so this can be outlined like that. Then we stop. We cannot outline this because this part is already inside what you are able to see, okay, clearly, which is the going to the left hand side. Okay, so we have outlined from here. Then if we come here, we also have got a left projection in terms of the helix. Stop here, right, that's also going to the left. Then we have got this part, right, that is also going to the left. Last but not least, in terms of those smaller helices which are going to the left, we have got this part. There you go. Okay, right, we can even close this part like that. No hidden detail is required, so we leave it like that for now. Okay, the next thing that you would require to do, right, once you have defined the big helix which is going to the left, the big helix which is going to the left, and the smaller one, right, we now start by defining the smaller helix which is going to the right. Okay, right, we are going to outline this part. There you go. Right, then there's a smaller one which is also going to the right. This procedure is very important in the description of a square spring, right? Then we also do this, going to the right, like that. Then from here, right. The next thing that you require is now to define that part of the helix which is going to the right but not interfering with what we've done. So if we look at this part, right, we are going to outline from here to there. Okay, then we stop there. Right, the other part is from here to there. All right, okay. Then you also have got this one, like that. Then you complete by showing this one, like that, okay. Now you have got your spring, right? This could be a tensile spring, it could be a compressional spring, right? It depends with the function. Remember, that would also be dependent upon the end, okay? Right, so that is a square spring, right? If it is two turns, you'd find that one face would show up, right? But if it is 1.5 turns, it's both up or both down. So we are saying this is face down, this is face up, okay? We are seeing this one as a section. That's the reason why we drew this line here, okay? To show the starting position. So I hope you liked what we did today in terms of this particular spring. Let me just check our time. Right, we still have got enough time to do another exercise here, okay? Right, so we are going to look at the one other exercise on the right-hand side. Let me just position so that you are able to see clearly. Right, so we are going to draw another exercise here. But what are the specifications? Right, the top view of a square spring showing the starting position. This is our starting position. Right, direction is right-handed. Turns it's 2, right, which means we are going to have 2 revolutions, right, and starting at the top again. So we maintain the direction of rotation. It's not going to change. Spring profile, that's 12 by 12, which is the same as that one. Then the pitch is basically the same. All right, okay. Now what I'm seeing here, the specifications are basically the same. So I'm not going to do the divisions here because the height and everything would remain the same. This is diameter 78, diameter 54, diameter 78, diameter 54. So I'm going to borrow these divisions on this other side. Right, let me project from here. We have got that. That is our basic center. Take this one down a little bit. Okay. I need to draw a line via the center. There you go. Let me just extend it. Right, so this is radius 27. It's the same radius, so I'm going to just draw a circle like this. Then radius 39 for 78 diameter. I'm also going to draw that one like that, okay? Now the height is the same. So here, but let me just project the first one from there and also the last one from there. Right, the divisions are basically the same, but what is different now is just the end, okay? So I'm not going to do the divisions here, I'm just going to project from them from here. But first of all, let's bring this one down. That's the first one. just to show. Show the link. There you go. Right. So the same divisions which are here, I've transferred them to this side. Right. Then the other thing is also to divide the top view into 12 equal parts. I make them cross slightly just to make sure that when I project, I see the point of connection. There you go. Right, so this time our point 0 is this side. Right, it's right-handed, so it should go in a clockwise direction. So that's point 1, point number 3, point 6, point 9, like that. Then we also have got our point 0 there. Right, so it's 1, 2, 3, 4, 5, 6, which is a half a pitch. 7, 8, 9, 10, 11, 12. Right, let me just verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 0. 1, 2, 3, 4, 5, 6. Right, wind up. 1, 2, 3, 4, 5, 6, which is 0. And 1, 2, 3. Okay, but the 3 is representing the 12 additional millimeters. Let me just take this one down slightly. Right, let me start with a big circle or the outside diameter. Right, project. There you go. Okay. Right, it's starting at the top, so this would be my point. That would be my point 0. Right, then 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, and 12. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Right. These points can now be connected. Right. We can connect them like this. Faintly, right, initially. Yes. Right, so these are the 2 10s from here. That's 1, then the second one. Then we start 3 divisions later, right? Remember, it's still 12 millimeters, which means same specifications with the first one. So we are going to say 1, 2, 3. That would be our point 0, right? So 0, then point 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12, 1, 2, 2 here, then 3, 4, 4, 5, 6, 7, 8, 9, 10, 11, 0. Okay. Then we connect again. There you go. Okay. Right. So these are the 2 helices. Right. Let me just do something which we did not do there. Right. The moment you have created these 2 helices, the big helices, you can even now outline going to the right, outline going to the right, since it's right-handed. So I'm going to outline here. Remember, when you outline, now you correct the small errors that we might have made. There you go. It's going to the right. Going to the right. Going to the right like that. It should be a smooth curve. Then you close the ends, right? This end. Close this. Right, you also close that. And this one too. Okay. You do the same this side. There you go. Okay. Right. The next thing that we want is not to project this one down. Right. Okay. Take this one down. There you go. Take your pen again. So this is the starting position, that's point 0. Then that's 1, that's 2, 3 is common, 4, 5, and 6, 7, 8, 9, 10, 11, 12. 1, 2, that's 1, that's 2, that's 3, it's common, 4, 5, 6, 7, 8, 9, 10, 11, and 0. Okay, right. We connect to this one faintly. There you go. Right. The next one, we also start at this point. That's 0, 1, 2, 3 common, 4, 5, 6, 7, 8, 9 is common, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 0. Okay. Faintly. There you go. Okay. Now we have got the 2 additional helices, but which are the smaller ones, which are attached to the supposed core diameter or the shaft. Right. Remember, we outlined the big one which is going to the right, the big one which is going to the right like that. The next thing that we want to do, right, is to outline the small one which is also going to the right. So I'm going to start with this one and stop here. Okay. Right. The other one is starting from here up until there. So I'm going to do this and stop there. It's also going to the right. Then there is one here up to there. Like that. Then there's another one from here to this point. So that's another helix. Right. Now, what it means, if you see that the lines which are going to the left, right, are going to that section, what it basically means, you need to define this. Unless if you are going there and closing like that, as if it was left-handed and ending here, then you were not going to see the section. But the moment that this is going to the left, which means it's going to expose that part of the section. So you are going to expose this, which is the 12 by 12 millimeter, like that. The moment you do that, you H, let me change direction, H, like this. Like that. Okay. Now, I've got the big helix going to the right, the big one going to the right, the big one going to the right, and the small one as well. The next thing now is to outline the small one, which is now going to the left. Okay, let me start with this one. Right, like I said, eye coordination is very important so that you see where you're coming from, but at the same time see where you are going. Okay, right, I'm going to outline this. Then you stop there, right? The other one that I would require is this one. Like that. Then I also have got this. stop there, okay? Right, once you have defined this, the next thing that you require to do now is to outline the big one, which is not going to interfere with the outlines which we have already defined at this point. So I'm also going to outline this. Okay. Then also this one. Like that. Then there is also here. Right. Last but not least is this one. There you go. Okay. Right. Then I can close it to the bottom like that. Now we have gotten now in terms of our spring, right? That is the spring which shows the two turns, right? So from here to there, that's one turn. From here to there, that's another turn, right? Now remember, don't forget the center lines. So there you go. This you would show as an outline to symbolize that edge. That's the center line. Right, so that's our top view and that's our front view in terms of the square spring, okay? Right, I hope you enjoyed the lesson as much as I did and you managed to grasp the concept that we intended to impart today, right? And remember, it does not only end there. You also need now to apply the same concept, right? When you are alone, right? In making sure that you have got the relevant experience, you can apply even in the examination. So boys and girls, I want you to take your paper, drawing board, and a pencil and do the work, okay? I hope you enjoyed this lesson and good night.